Hello, this is Chlorine from Exam Help Lab. Today I'll be solving Chemistry Paper 2 AS Level Structured Questions 9701, Paper 2, written to February-March 2018. Question number 1, Part A. The graph shows a sketch of the first ionization energies of 6 successive elements in the periodic table. The letters are not the symbols of the elements. Part 1, explain what is meant by the term first ionization energy. So this is energy required to remove an electron from 1 mole of a gaseous atom. Part 2 suggests why the first ionization energy of B is much less than that of A. So generally what happens if we talk about period 3 elements starting from sodium, Na, and the next 5 successive elements, which are magnesium, aluminum, silicon, phosphorus, and sulfur. Magnesium will have a little higher ionization energy than sodium because it has a complete orbital. Ionization energy generally increases across a period because of the increase in nuclear charge all the way from sodium to chlorine, while shielding remains constant within a period. So this higher bar basically tells us that the electron being removed out of A is not in the shell as electrons in B, C, and rest of them are. In fact, it's an inner shell, so we can write that B has its outer electron in a higher energy level that experiences greater shielding, and hence there is less attraction between the electrons and the nucleus. So the 3 points which we need to mention are that B has its outer electron in a higher energy level, because if all the elements ranging from A to F were in the same period, this bar wouldn't have been this higher. They would all be having similar heights if they were all from the same period. And the second point would be that this element B experiences greater shielding, and hence there is less attraction between electrons of B in the nucleus. Part B, P to G are successive elements in period 3 of the periodic table. The letters are not the symbols of the elements. On the axis, sketch a graph to show the trend in the atomic radius of the elements P to T. Explain your answer. So atomic radius decreases along period 3, so we'll have a negative gradient slope, with B having a much greater atomic radius, and T among them will be having the smallest atomic radius. There's going to be a straight line but with a negative gradient, and the reason to that is that the nuclear charge increases along a period, and as we go along a period, electrons are going to be added in the same shell. The more the electrons, the greater the amount of attraction between nucleus and electrons. The atom starts to shrink, and hence the radius decreases. So we can write that nuclear charge increases as we go along period 3. And electrons are in the same shell. Each added electron along a period is going to be added to the same shell. And the more the number of electrons, there is going to be a greater the amount of attraction between nucleus and electrons. Question number 2, carbon and silicon are elements in group 14, C60, and diamond are allotropes of carbon. Describe the lattice structure of C60. So C60 is a Buckminster fullerene that has each carbon atom bonded to the other 3 carbon atoms, just like that of graphite. So C60 has got a simple molecular structure. And carbon atoms are regularly arranged in a fused ring structure with exactly 20 hexagons and 12 pentagons in C60. So the other point could be that carbon atoms are regularly arranged but 2C60 sublimes at about 800K. Diamond also sublimes, but only above 3800K. Explain why C60 and diamond sublime at such different temperatures. The C60 molecules have both covalent bonds and weak intermolecular forces that are too weak, whereas diamond has got strong covalent bonds and it has also got strong intermolecular forces which are stronger than that of C60 molecules. Thus, diamond requires greater energy to break its bonds. So we can write that C60 has weak intermolecular forces and covalent bonds, whereas diamond has strong covalent bonds which are stronger than that of C60. Thus, diamond requires higher energy to break its bonds. Part B, C60 forms hydrocarbons with similar chemical properties to those of alkenes. One such hydrocarbon is C60H18. State what is meant by the term hydrocarbon. So these are compounds or molecules that are only made up of carbon and hydrogen atoms. But to describe a test to indicate the presence of double bonds between carbon atoms give the result of the test. So for an unsaturated compound, we can use bromine water. And if the solution changes to colorless from brown, then that's a positive result, meaning that that double bonds are present. So positive result would be brown to colorless. Part C, 0.144 grams of C60 was placed in a 100 centimeter cube container of hydrogen gas at 20 degrees Celsius and 10 to the power 5 pascals of pressure. The container was heated to make the C60 and hydrogen gas react. The reaction occurred as shown in the equation. After the reaction, the container was allowed to cool to 20 degrees Celsius. The pressure decreased to 2.21 into 10 to the power of 4 pascals. All of the C60 had reacted. Part 1 being the type of reaction that occurred. So addition of hydrogen to C60. So this is addition reaction. Part 2, calculate the amount in moles of C60 that reacted. So moles of C60 is going to be the mass of C60 divided by the molar mass of C60. The mass of C60 being used in this part of the question is 0.144 grams divided by the molar mass of C60 is going to be 12 into 60. And hence we have the amount of C60 as 2 into 10 to the power of negative 4 moles. So 2 into 10 to the power of negative moles of C60 had reacted with an excess of hydrogen gas. Part 3, calculate the amount in moles of hydrogen gas that reacted with C60. So since hydrogen gas was in excess, so we're not going to consider ratio in our calculation. Instead, we are going to use PV is equals to nRT formula. And we have been given enough data to use that equation. So the pressure of hydrogen gas that reacted is going to be the difference between the initial pressure and the final pressure after the reaction. So 10 to the power of 5 minus 2.21 into 10 to the power of 4 is going to be the pressure of hydrogen gas that was used in the reaction. The volume of the hydrogen gas which was being used is 100 centimeter cube, but for PV is equals to nRT equation, we are going to convert that to meter cube. So 100 divided by 100 cube. To convert that to meters cube, we are going to have R as 8.314 since that's a constant, and the temperature being used over here is 20 degrees Celsius, which is also equal to 293 kelvins. Now, by using the formula N is equals to PV divided by RT, we are going to have 0.00320 moles of hydrogen gas that reacted with 2 into 10 to the power of negative 4 moles of C60. Part 4, use your answers from part 2 and 3 to deduce the molecular formula of the hydrocarbon C60H2X. Okay, so from the previous part, we got to know that 2 into 10 to the power of negative 4 moles of C60 reacted with 0.00320 moles of H2 gas. Now, which means that now 1 mole of C60 would require 1 into 0.00320 divided by 2 into 10 to the power of negative 4, which is 16 moles. So 1 mole of C60 would require 16 moles of hydrogen gas. That means that X from here has a value of 16, and 16 moles of hydrogen gas will react with 1 whole mole of C60 to produce C60H2X, where X has a value of 16, so it will give a molecule which will have a molecular formula of C60H2X, which means 2 into 16, and that's 32, C60H32. Part D, silicon shows the same kind of bonding and structure as diamond. State the type of bonding and structure shown by silicon. So just like that of diamond, silicon has strong covalent bonds. It has giant molecular structure. Part 2, when silicon reacts with magnesium, Mg2Si forms. Mg2Si is thought to contain the Si4- ion. State the full electronic configuration of the Si4- ion. Okay, so for configuration of any ion, whether anion or cation, you're first advised to write its atom's electronic configuration, like that of silicon. So silicon atom has an electronic configuration of 1s2, 2s2, 2p6, 3s2, and 3p2. Now to add 4 more electrons to make the silicon atom change to silicon 4- ion, it would become 1s2, 2s2, 2p6, 3s2, and 3p6. 4 electrons were added to the highest energy level over here. Part 3, solid Mg2Si reacts with dilute hydrochloric acid to form gaseous SiH4 and a solution of magnesium chloride. Write an equation to show the reaction of solid Mg2Si with dilute hydrochloric acid. Include state symbols. So Mg2Si is in its solid form. You're going to write solid plus dilute hydrochloric acid. So that's an aqueous state. That gives gaseous SiH4. So that's gas. Plus a solution of magnesium chloride. That's again aqueous. That's again in aqueous state. Now we need to also balance our equation. So we're going to have 4 moles of HCl and we're going to have 2 moles of magnesium chloride. Part 4, predict the shape of SiH4 molecule. Okay, so a silicon has four outermost electrons to make bonds, and each hydrogen atom can only make a single bond with silicon. So just like that of CH4, where carbon attaches to four hydrogen atoms, here silicon is going to attach to four hydrogen atoms, and that's how it takes a tetrahedral shape. So it's going to have a tetrahedral shape, just like CH4. Part 5, SiH4 reacts spontaneously with oxygen to produce a white solid and a colorless liquid that turns in hydroscopy to sulfate blue. No other products are formed. Write an equation for the reaction of SiH4 with oxygen. State symbols are not required. So what's that one thing that turns anhydrous copper sulfate blue? Anhydrous copper sulfate is white in color, and water is that one thing that upon addition changes it to blue. So we're going to have SiH4 plus oxygen. It produces something that changes anhydrous copper to sulfate to blue color, so that is water. And the white solid they're talking about over here is the silicon dioxide. Now we also need to balance our equation, so we will have 2 moles of oxygen and 2 moles of water molecule. Question number 3, calcium and its compounds have a large variety of applications. Calcium metal reacts readily with most acids. Write an equation for the reaction of calcium with dilute nitric acid. So calcium plus HNO3, that will give me a salt, that's calcium nitrate, and hydrogen gas. Now we'll have 2 moles of nitric acid to balance our equation. Part 2, when calcium metal is placed in dilute sulfuric acid, it reacts vigorously at first. After a short time, a crust of calcium sulfate forms on the calcium metal and the reaction stops. Some of the calcium metal and dilute sulfuric acid remain unreacted. Suggest an explanation for these observations. Okay, so at first, a crust of calcium sulfate starts to form, which indicates that calcium sulfate isn't reacting. So we can write that calcium sulfate does not react. Second is that calcium sulfate forms crust on calcium metal, and some calcium and sulfuric acid remain unreacted. This shows that this crust of calcium sulfate is preventing reaction between dilute sulfuric acid and calcium metal. So we can also write that calcium sulfate crust prevents reaction between sulfuric acid and calcium metal. Part B, calcium ethane dioate is formed when calcium reacts with ethane dioic acid. The compound contains one cation and one anion. Part 1, draw the dot and cross diagram of the cation present in calcium ethane dioate. Show all electrons. So first I'll write the equation for the reaction, that is calcium plus ethane dioic acid, which is COOH and COOH. Now this will form an anion, which is going to be COO negative, COO negative. Now this was the anion, and the cation present over here is going to be just Ca2 plus. The dot and cross diagram for the cation, calcium is going to lose 2 electrons, and that will be given to this anion. So Ca has its first shell with 2 electrons, the second shell 8 electrons, and the third complete shell. You're also going to notate that with 2 plus here. Part 2, draw the displayed formula of the anion present in calcium ethane dioate. So as I told you before, this was the anion. We're going to have a negative charge on this oxygen and a negative charge on this oxygen. Part C, calcium chlorate is used as an alternative to sodium chlorate in some household products. Part 1 suggests the use for calcium chlorate. It can be used as a bleach. Part 2, the chloride ion is formed when cold aqueous sodium hydroxide reacts with chlorine. So reaction between cold sodium hydroxide and chlorine is It's going to produce NaCO plus NaClO plus water. Since they're asking us to write the ionic equation, it's going to be OH minus plus chlorine gas. That gives Cl minus plus chlorate 1 plus water. And we also need to balance our equation. Part 3, the chloride 1 ion is unstable and decomposes when heated as shown. Deduce the oxidation number of chlorine in each species. Complete the boxes. Now the oxidation number for any ion is going to be its charge, so this is going to be -1. Over here, oxygen has an oxidation of -2, and suppose that chlorine has an oxidation state of X, so we are going to have their sum equal to their combined charge, which is -1. So X will have a charge of +5. Part 4, in terms of electron transfer, state what happens to the chlorine in the reaction in part 3. So it's going to be, it's from +1 to -1, this is reduction because there is a decrease in oxidation number, and that's reduction. +1 to +5 is oxidation because that's an increase in oxidation number. So we'll write that chlorine gains and loses electrons. Part D, calcium lactate is used in some medicines. It forms when lactic acid reacts with calcium carbonate. Part 1, identify the other two products of the reaction of lactic acid with calcium carbonate. So acid plus metal carbonate gives you carbon dioxide and water too, other than the salt. So we'll write that carbon dioxide and water. Part 2, two possible methods of making lactic acid are shown. Part 2 states suitable reagents and conditions for reactions 1 and 3. So reaction 1 is aldehyde, this aldehyde group to nitrile group and also alcohol group, which is nucleophilic addition reaction. Now reaction 2 is nitrile group to carboxylic acid group, which is addition of HCl and water. Reaction 3 is oxidation with acidified chromate ion, where the secondary alcohol changes to ketone group and this primary alcohol changes to carboxylic acid group. And at last, reaction 4 is reduction of just ketone, not COOH group, which means that NaBH4 was used as a reducing agent rather than LiAlH4. Now, part 2, state suitable reagents and conditions for reactions 1 and 3. So as I described before, that reaction 1 is the change from aldehyde to nitrile and alcohol group, which is nucleophilic addition reaction. This nucleophilic addition reaction requires a reagent called HCN, and we are going to also have NaCN being used as catalyst. Reaction 3 requires reaction 3 was all about oxidation of secondary and primary alcohol. So this oxidation will require acidified chromate ion, and it also has a condition that it requires heat under reflux. Part 3, name the type of reaction that occurs in reaction 2. So reaction 2 was change from nitrile group to carboxylic acid. So this was hydrolysis because we were using a water plus HCl. Part 4, reaction 4 uses NaBH4. Identify the role of NaBH4 in this reaction. Reaction 4 was reduction of ketone group to secondary alcohol. So NaBH4 was being used as reducing agent to reduce ketone to secondary alcohol. Part 5, lactic acid has a chiral center. State what is meant by the term chiral center. So this is central carbon atom bonded to 4 different atoms or group of atoms. Question number 4, cyclohexane is a colorless liquid used in industry to produce synthetic fibers. A reaction scheme involving cyclohexane is shown. Part A, reaction 1 involves a free radical substitution mechanism. State the essential condition required for reaction 1 to occur. So free radical substitution reactions require UV light. Part 2, complete the table to give details of the mechanism in reaction 1. So this step is called initiation step, where chlorine molecules will break into chlorine radicals homolytically. In propagation step, a radical reacts with one of the reactants, forming one more radical, that is this one, and one of the products, which is going to be HCl. Now that same radical, which is forming in the first propagation step, will react with one of the reactants and that forms one more radical, that is chlorine radical, and one of the products, that is this structure. So this also is part of propagation. Now lastly, in termination, radicals will react among themselves. Like here, these two, both of them, they are radicals. They will react among themselves and they will form a desired product like this structure. Part B, name the type of reaction that occurs in reaction 2. So reaction 2 is removing Cl and removing one hydrogen atom, and then we will have an unsaturated compound. So this is elimination. Part C, the product of reaction 2, cyclohexane. Cyclohexane can be converted into adipic acid. Identify the reagents and conditions for the conversion of cyclohexane into adipic acid. So to convert any unsaturated hydrocarbon to acid or ketone group, we always use hot concentrated acidified KMnO4. You can write that hot concentrated acidified KMnO4. Part 2 suggests three main differences between the infrared spectra of cyclohexane and adipic acid. In each case, identify the bond responsible and its characteristic absorption range in wave numbers. So cyclohexane most importantly has C to C double bond, which adipic acid doesn't. So we will have an absorption at 1500. You can look up for these values in the data booklet, which will be provided to you in during your examination for cyclohexane. Due to C to C double bond. Now second is that adipic acid has C2O double bond, which cyclohexane doesn't. So due to C2O double bond, we are going to have another absorption. So we can write that due to C2O double bond, an absorption at 1640 to 1750 per centimeter for adipic acid. At last, adipic acid has a carboxylic acid group, which cyclohexane doesn't. So you can write that adipic acid has an absorption at 2500 to 3000 per centimeter due to carboxylic acid group. So that was the end of the paper. Thank you for watching.